your STI, Schrodinger time-independent equation, will be of this form. Okay, du squared dx squared equals plus beta squared u. Right, done that before. Right, because it'll be exponentially decaying type solutions. So in this region here, your u1 will be of this general form. So it'll be a exponential beta x plus b exponential minus beta x. That's your general solution to this equation. Now, if your b is not too large, this one will not blow up, right? Because there's not enough. If you're little b, don't be confused with little b and beta, right? So if your b here is fairly small, this value here will not blow up to infinity. So we leave it in, we don't kill it. But in region 2, x goes out to infinity. So we have to kill this term, right? Because that would blow up. So in region 2, your wave function is of this form. So just some other constant, c exponential minus beta x, right? Now, okay, so we now have two general forms for the wave function in region 1 and in region 2. Now you can imagine what's coming. You've probably seen the writing on the wall. What we do now is, well, two things. We start applying our constraints, the usual constraints we impose on the wave functions. Remember what they were again? Single valued, normalizable, and continuity. And the continuity is of two types. Continuity of the values, they have the same value at the boundary point, and the gradients at the boundary point have to be equal. So it's really sort of like four conditions. Okay? And of course, common sense, given all this difference of gradients discussion, of course that will come into it as well. But I've run out of board, and I have finished this session. Oh, by the way, before I do finish off, let me make, because you will notice, if you're following me closely and studying these lectures, from now on, you're going to notice some changes. And one is, thanks to the wonderful help that I got from my son-in-law, I'm now able to film in high definition. Admittedly, you have to compress it, and we might even be able to do even more. We might be able to film, because I noticed on my camcorder there are degrees of high definition. I think. So I need to study this more. So if so, I might be able to film in even higher definition, and it would, if that's true, then maybe the writing would become even clearer. That would be great. No promises. That's a suspicion. I'm just playing around with my camera. See, I don't have any advisor or expert who tells me how to do this. I'm sort of culturally isolated as a Westerner in China. I virtually live indoors, especially when it's so hot. So I just have to discover everything the hard way by trial and error. But anyway, now the writing is a lot clearer than it was in standard definition, STD. And the other thing is, my son-in-law fiddled with the parameters of the compression in the compression program, such that the upload time now from here to YouTube is, I don't know, maybe half, that kind of thing. So I can now upload more video clips per day to YouTube. And so I'm thinking of having not just 2 sessions a day, but 3. It's still only about 1.5 hours a day. I can cope with that. It's not, the workload's not too much. And that's a good thing, because I'm rather worried long term. I'm really hoping to do PhD 2 level within not too many years. So the overall rate that I'm uploading is an important factor. So if I can increase it by 50%, that would be great. So expect that. There will just be the uploading will just get faster. There will be more video clips uploaded per day than in the past, as a result, as a consequence of the upload time being halved pretty much. And I will talk again with my son-in-law about the possibility of perhaps, no promises, perhaps increasing the degree of high fidelity again. And we're working on this. I don't know if you do, please email me. I don't know. My email address is here, profhugodegaris@yahoo.com. So please email me if you know of people who are doing much the same kind of thing that I'm doing, giving home lectures for free. If they have technical solutions superior to what I'm doing, I'd be very grateful to hear about them. So please contact me. All right. So expect further changes. You're well into the second course now. Things are still evolving. So first course was finite group theory. This second course is on quantum mechanics. The third course will be a computer theory type course on theory of computation. The fourth course I decided recently would be on special relativity at senior level. And I'm thinking for the fifth course will probably be another math course, because I've already done 2 physics courses, on complex analysis. In other words, the calculus of complex numbers. So differentiating complex functions and integrating complex functions, which is very important. Those techniques get used in quantum field theory, QFT, get used a lot. Complex analysis also needed for something called Riemann surfaces. Don't worry about what they are if you don't know. But Riemann surfaces play a critical role in string theory. And string theory is the great white hope to solve, well, effectively everything. The TOE, the theory of everything. So in other words, the 4 major forces of nature, the strong nuclear force, the weak nuclear force, the electromagnetic force, and the gravitational force, and predict all the masses and properties, all the elementary particles and so forth. So that's the big hope that string theory may do that. And I'll definitely, if you stay with me, this is a long-term commitment, right? So if you're young, you may see me age, right, as the years and even the decades pass. So if I can increase my upload speed by a factor of, by doubling it, the speed, so I can halve the time, so I can upload more material per day. There'll be more courses, and I advertise, it may sound a bit ridiculous, but I advertise about 600 courses before I die, in about 3 decades, hopefully. So a lot of courses, and hence a lot of lecturing time. So I hope you will follow me for years, if I'm not outdated by superior ways of doing things, which is quite possible. 3 decades is a long time, especially in the technological world. Anyway, so Riemann surfaces are a very important topic for string theory, and I need complex analysis to, it's a multiple step chain of reasoning. I need complex analysis, that's the calculus of complex functions, differentiating and integrating them. I need that to understand quantum field theory, which uses these techniques a lot. I need quantum field theory and Riemann surfaces to do string theory. And I'll be doing a lot of courses on string theory because it's a beautiful, wonderful subject. I mean, just even if string theory fails, which is highly unlikely. I mean, there's already quite strong indirect evidence that that string theory works, and I'll talk about that when the time comes. So, but even if string theory is relatively a failure as physics goes, and I doubt that very much. I think there's too many clues that that it's working. But just the contribution that string theory alone has given to mathematics is enormous, because the mathematics of string theory is really beautiful, powerful and beautiful. And I get quite emotional when thinking about this stuff, because if you devote like the rest of my life, the next 30 years or so, is devoted to this kind of stuff. So obviously speaking about an intellectual passion here, and string theory and other branches of math, but string theory is just so powerful and so beautiful. It gives me a lump in my throat, and I hope I can persuade you to feel similarly. I hope to inspire with the sheer power and beauty of string theory. It's just awe-inspiring.